try to solve one concept question for the final. And this problem occurred like 2 years back in the environmental engineering final, and I would like to explain this solution to this problem. The ocean outfall diffuser that discharges polluted wastewater into Kuwait Bay, okay, is located 5,000 meters from the public beach. So the pipe or the outfall is entering the Kuwait Bay and extends 5,000 meters inside Kuwait Bay. Okay. There are 10 to the 5 coliform bacteria per milliliter in wastewater. So in this wastewater, there is 10 to the 5 coliform bacteria per milliliter. The amount of drainage discharge is 0.3 meter cubic per second. So we have concentration of bacteria and we have flow rate inside the outfall. Okay, and we know it's 5,000 meters extending inside the Kuwait Bay. The first order coliform death rate in seawater is approximately 0.3 per hour. So we have K. The current pushes the wastewater plume into the beach. So here, the wastewater is leaving the outfall. Again, it's 5 kilometers inside the Gulf. It's pushing the wastewater inside the Gulf. And then there is the current, seawater current, or the Gulf current, is pushing this wastewater back to the beach. And this rate is 0.5 meter per second. The ocean current can be approximated as a pipe holding 600 meter cubic per second. So I'm assuming that this push of current is approximated by a pipe holding 600 meter cubic per second of seawater. Determine the concentration of the chloroform at the beach. We need to find out the concentration of chloroform here at the beach, because people go and swim, and some people they go and sit down and they want to eat their food. So we need to make sure if this beach is polluted with, of course, coliform. So first of all, we will assume that the current going from the beach toward from the Gulf toward the beach is modeled as a blood flow reactor, and that the wastewater is completely blended in the current at the discharge point. So here there is a blending between the current and the wastewater leaving the pipeline. Okay? And of course, this is not here. The coliform level at designated swimming beaches, this is from the EPA, the US EPA, should not exceed 88 per 100 milliliter. So this is the standard. If it's above than 88 per 100 milliliter, well, now we could assume that this beach you could swim in it. In any one sample, so look at this, in any one sample, or exceed a 3 samples average over a 60-day period of 47 per 100 ml. So either one of them, if you have one sample, should be 88 per 100 or lower to allow the people to swim, or if you have like a 3 sample average over a 60-day period, and there should be 47 chloroform per 100 ml. Let's look at the solution to this problem. And we were given the flow rate, 0.3 meter cubic per second, and we have the concentration, 10 to the 5 chloroform bacteria per milliliter, and we have K, 0.3 per hour. And we have the current with a velocity 0.5 meter per second And of course, the current is this way and this way. It's pushing it this way, and it's pushing the wastewater this way after it mixes with the wastewater. Now, let's go at mixing. What is the N? We have one N. We have concentration. Of course, we have to make it N equal out. So the N is concentration N times flow rate N equal concentration out, flow rate out. Now what is the concentration N? You can see it here, 10 to the 5 chloroform per ml times the flow rate. The flow rate is 0.3 meter cubic per second. You could keep these things, don't play with the units because it will cancel out with the units on the right hand side. And here, the concentration of the ocean, here, the mixed ocean is unknown times the flow rate, and he mentioned here that the flow rate was around, assuming 600 meter cubic per second, assuming it's like a pipe holding 600 meter cubic per second. So 600 meter cubic per second, and this, you will rearrange the equation and you will get the concentration of the ocean mixed, 10 to the 5 times 0.3 over 600, and that will give you 50 coliform per milliliter. Make sure that the units are the same because this will cancel with this, okay? And you'll end up with chloroform per ml. So this is the concentration at this point. Let's just erase this so you can see. So at this point, mixing between the seawater and the wastewater, at this it is 50 coliform per milliliter. And we could see that the 50 milliliter is lower than 88, which is like 5 kilometers from the beaches, which should be acceptable for swimming, but you should watch out the 47. Now we're gonna come and see at the beach. So we have to see, is it like 3 sample average over 60 days, or is it like 1 sample and it's 88? So we'll look now. First of all, we have to find out the travel time for mixing, from mixing point to the beach. You know the travel time, the time is equal distance over velocity. Remember, distance is in meter, the time is equal, distance is in meter, and the velocity is meter per second. So meter with meter, you could see second at the top. So now this is the time, distance over velocity. So we know the distance, it's 5,000 meters. And you divide by the velocity given, the velocity of the current is 0.5 meter per second. And that will give you 10,000 seconds. You could convert second to minute and minute to hour. You will end up with 2.7 hours. So it will take this mixed seawater with wastewater, how many hours to reach the beach? 2.78 hours. And since we are assuming the seawater with the wastewater is moving like a plug, so we should use the equation for the plug. C at the beach, this is given from this equation. C final is equal C naught E minus KT. So C beach, which is the final, this is the final here. So this is the final, and this is the initial. So we will find the C beach, C final, and this is equal C ocean mix, which is C initial, e to the power minus KT, and we have C ocean mix, which is like 50 from here. E to the power minus K, K is known, and time is known, 2.78 hours. Remember, it's hours here, and 0.3 has to be per hour. You know, you have to make sure that the units are homogeneous. Later on, you will get 21.7 chloroform per ml. So, which means that the concentration of coliform is 21.7 or 22.7 or 22 coliform per milliliter, and this one is way less than the 88, and also less than the average of the 3 sample average over 60 days. So whatever values that you are getting, it should be less than this, and you could allow the people to swim in the